Hi there. In the previous installment, I've been telling you about different ways to calculate the total wellness. In this video, I'm gonna talk more about importance of context when evaluating those mentioned z-scores, both in different categories and in total wellness score. Let's start with a hypothetical example where we have couple of days. This is a calendar, so we can have different days. I'm just going to draw this quickly. So imagine this is a calendar of I'm not so sure how many days this is, but it's going to serve a purpose. So let's say this is a Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So as we know, let's say I want to evaluate this guy over here. The most common option is to have something that's called a rolling average. 1, 2, 3, 4, 5, 6, 7. So I calculate the rolling average of these preceding days and compare it to this score on a given day. In a previous video, I spoke about calculating the negative wellness by summing up the negative z-scores for each category. But you can use this method is used in that particular example. It could be used in a most simple one, and that's a basic sum of the categories. So the problem with this one is that let's say I have a game over here. Let me just select another color. So let's say I have a game over here. Sorry. So let's say I have a game. This is a game here. And because of this game, I'm going to be pretty sore on this given day. So I'm comparing one instance to some rolling average, and of course we're gonna reach minus, especially if in this sample we don't have a game. So I'm not catching similar data, and of course then I'm gonna trigger all the alarms, because probably gonna be -1 to -2 standard deviations compared to this. So that's problematic, because I'm comparing this number to some random duration rolling average, and we can have similar day in this region or not. So the point is that if I want to compare this day, so I want to compare this day, I want to not compare it to some random sample, but I wanted to compare to similar days, or at least or same day. So I want to compare this to this day, and if I have a game over here, that's Wednesday, so I wanted to compare it to this day also. So if my normal reaction is different, then that should be alarming. But it's normal that this day I feel the worst. Then I'm kind of rebounding. So this is a game day. I'm feeling great. Then drop further, and maybe on the third day I'm going back to the baseline, and then climbing up again toward the next game. So what I want to do is I want to compare this instance to something similar happening here. So if this is, of course, this is going to be a drop compared to the rolling average of these guys. But if this is completely different or completely untypical to a couple of similar instances, then that should be a bit warning if this is dropping more than what's typical for a given player. So as we said in this example, the game provides context. So there are a couple of solutions to this. Let me draw something. Let me just clear up this. So first, what we can do first is instead of comparing one day, so if this is our last day, we want to compare it, the reaction on this day, we want to compare it to something that's baseline. What we can do instead of just comparing a single day, we can compare multiple days. So we can compare maybe 3 to 7 days and compare it to some baseline. That could be also rolling. So if this is a baseline, that should be something that's a longer duration, maybe 28 days or more, over 28 days. So using multiple days, I'm kind of filtering or smoothing out those hills and spikes. So then we compare, basically calculate the fx size. Fx size, that's a if this is x and this is, or call it, yeah, x, and this is b, that's a baseline. Then we basically average of those 3 days minus average of the baseline divided by standard deviation of the baseline. And that could be used also to calculate how different these guys are, and we're probably gonna filter out or smooth those spikes and get a little bit of more trend and not overreact to on a given day. Second option is to provide some form of a context information. So this is our calendar. These are the days. So for this guy, what we can do is we can also provide as a parameter the training load in the preceding days. Let me just select another color. So we can select we can take the average load of the 3 or more preceding days, and then we can compare. We can see what's the reaction, basically create a scatter. So if this is wellness, let's say a total wellness, and this is training load, or the average training load over last 3 days, then we can get a scatter. Maybe get a certain reaction and see how far off we are on that the normal trend. So that's method number 2. I haven't been experimenting with this one, and the last method, actually before going there, this is what you can do also is to instead of just create a training load that's a continuous variable or ratio or interval scale, you can create discrete variables. So we can rate training load in the preceding 3 days or a preceding training as easy, medium, hard, very hard. This is idea by John Light, and this gives us some form of a context. So if I compare this to some rolling average, my pen is not working, I don't know why. So if I compare this day, the z-score of training wellness to some form of a rolling average over here. These guys give me some form of a context, so I'm not overreacting. And if I say, okay, this was a hard training session, so very hard, then I know, is probably gonna, overreact to it. And then if I pull out similar cases, so if I pull out similar case, then this might be a similar case, and where we had also a very hard session over here, and then I can compare these two guys and see how far how untypical this reaction to the similar scenario, and then I can make some causal claims. Again, just giving some type of either discrete classification of the previous training there, or previous 3 or 4 or whatever, giving some form of a context. And the third option is this one. So option number 3 is taking game into context. So I've been using this method during the last year. So let me just draw a couple of games. If I had a game here and here, so what can I do is to say this is a 0 day. This is +1, +2, +3, +4, +6, and over 3 you can classify that as more than +3 or more than +4, and going in reverse, this is -1, -2, -3, -4, and so forth. So the context parameters in this case are days before and after the game. Another option could be days after the day off. I know my handwriting sucks, but so again, if we are comparing this guy over here, the wellness score of this, and I know this is +1, +2, +3, +4, +5. I want to compare this to not just a rolling average, but kind of a rolling average of +5 days, or the days that are done 5 days after a game, and then I compare this day to rolling average and a rolling standard deviation, and see how far a given player is off to a normal reaction. You don't need to have different. You don't need to have like +2, +3. Sometimes in a preseason it's going to be +30. So instead of just counting, you can have 3 or 4 groups. It could be +1, +2, +3, maybe 4 to 7 and over 7. So these are just classes, and we can use this to pull the data. Same thing for a day off. So the whole point of this lecture is that instead of comparing a given day to just a rolling average and hope to catch something, we want to give a context to a given day and compare it to the similar days happening under similar context. And in that case that could be days after a game, or classifying training that happened 1 or 2 or 3 days before a given day, and comparing what's happening to training reaction, to athletes reaction, using the context as a criteria or under the similar situation. This could be pretty hard to code in Excel. Maybe using a power pivot and programming, so you filter out the days. But in a smart database is quite easy to program this. You can just link. You can calculate the days after a game if you have an event where you code the game, and then you can calculate the days difference, and filter the selection in the history, and then just calculate the standard deviation and standard mean. Hopefully this makes sense. It makes things much more complex, but I guess it makes it more precise. Till next time, guys, try to code this and try to implement this in your own scenarios. Take care. Bye bye.